Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our playlist of simple reservoir simulation and modeling. And again, we will use the navigator to perform the simple modeling. And I think I will create some videos, more than one video about this topic. And this is the topic of simple modeling for oil reservoir. Okay, it's a simple well model. So by simple well model, I mean that I will make one model, in this case, one well, one producer, okay, in a specific simple reservoir. Okay, so here we go. And for this specific video, I think I will just only show you or explain to you the code, the script. Okay, this is my model. And I will click on this one, union. Right, so this is our model and I have only one producer there. I call it prod. So let's check what we have here. So files, simple oil data. Okay. Okay, so we will start with this data set. It's very simple. So as usual, we will start with run spec and dimensions. This is for the dimension, the number of grids in X direction, Y direction, and 10 direction. By the way, I modify a little bit the simple model for CO2 storage. Okay, so you can see if you check my previous videos about simple modeling in CO2 storage, I use dimension of 21, 21, and 10. So I use the same model, but I modify a little bit to make it an oil reservoir and oil production well. Okay, so we continue with field. I'm going to use field unit, and then this is the phases that we will involve in the model. So oil, water, gas, and dissolved gas. And this is the setting for the table for equilibrium, for the well, all right, and for the properties, okay, and scaling for the relative permeability. And because this is a simple model, the date is not very meaningful. So I just use it 1 July 2018, but the start is important. Okay, the keyword start is important. And this is for the run control. If you are performing simple modeling, so you can just follow this DT max original 200, DT mean, and well equations. Okay, so this is just the setting for the entire work, the entire simulation. Okay. All right, so now we will enter the grid section. Start with init for initialization, and this is the minimum pore volume that we will allow in this model. Okay, you can see we allow a very small pore volume, but for simple reservoir modeling, it's not very useful, by the way, because we will not do a very complicated simulation, right? In very complicated simulation, sometimes you need to allow this very small pore volume to exist in your model. But this is a simple model, okay? So you can just like do something like this, okay? Or you can still use minimum pore volume, okay? And then it's very important, the properties. I use equal, so I mean that I will make a uniform property. So the first one is porosity, 20% for all the grid. Okay, so this is the setting, poro 0.2 for 20%, from grid 1 to 21 in X direction, 1 to 21 in Y direction, and 1 to 10 in, Z direction. And then perm X, homogeneous, perm Y, also homogeneous, 200 and 200 millidarcies. Perm Z, I make it 30%, more or less 30% of the horizontal permeability. So I input 70 millidarcies. Okay, but I make a heterogeneity condition for this reservoir in Z direction, where I use perm Z of 70 for grid number 1 and 2, and then I make a tight layer, okay, at Z of 3, because I want to test it whether this buffle or this barrier will work to prevent the production. And also still 70 for Z equals to 4 to Z of 10. Okay, and then this is dz, the thickness in Z direction. I make it 25 for the first two layers. And then for the buffle, I make it very thin, 0.3 feet for the Z of 3. And then after that, I make it a little bit thicker, 28 feet for grid number 4 to 10. And tops is the top of reservoir. And then I again use equals for the size of grid in X and Y direction. I make it 150. Okay, so so it's like this, and then we enter the property section.